The periodic table put forth by Mendeleev was quite well defined, but it wasn't the best table ever. Why do I say so? It's because with time, the number of elements being discovered increased, and fitting them into the table according to the periodic law by Mendeleev seemed difficult. Also, we have taken a look at the major limitations of the periodic table by Mendeleev. So with all these limitations, how do we study the elements? How do we carry out the periodic classification? Well, if the elements discovered later did not follow the periodic law given by Mendeleev, then the only way to arrange them was by modifying the law. Yes, this was however not what scientists could think of as the first step. It was quite gradually that the scientists realized the fact that the law could be modified. But how did this happen? It was around 1913 that the British physicist Henry Moseley found an interesting fact. He realized that instead of atomic mass, all the elements will show periodicity if arranged on the basis of their atomic numbers. Wait a second, did I just say atomic number? Isn't atomic number a randomly assigned number to the atom by us? Actually not. Atomic number of any element is never a randomly assigned number. It is basically the number of protons present in the nucleus of the atom of that element. For instance, let us consider the first 4 elements in the table. So we get atomic numbers of hydrogen as 1, helium as 2, lithium as 3, and beryllium as 4. So why are these elements assigned these particular atomic numbers only? Can we change these numbers ever? No, we can't. That is because they have these respective numbers of protons in their nuclei. Hydrogen has just 1 proton in its nucleus. Similarly, helium has 2 and lithium has 3. And how many protons will beryllium have? Correct, it has 4 protons. The same is valid for other elements as well. Coming back to the table, did Henry Moseley think that characteristics of elements are based on their atomic numbers and not their atomic masses? Yes, that's what he meant. And with this, there emerged a new law of studying the periodicity of elements. It was called the modern periodic law. The law stated that the properties of elements are periodic functions of atomic numbers. So what does this mean? This means that the physical and chemical properties of elements do occur periodically. But this happens when the elements are arranged according to their atomic numbers. All the known elements could be arranged based on their atomic numbers. With this, predicting the properties of elements yet to be discovered got simpler and more precise. This helped in placing the newly discovered elements properly in the periodic table. Also, overcoming the limitations of Mendeleev's table was another advantage. And how did that happen? Do you remember the limitations? The first limitation of no precise position for hydrogen was mainly overcome. It was assigned a position that would not lead to any confusion. We will take a detailed look at this position of hydrogen later in the higher grades. Next limitation of the Mendeleev's table was the position of isotopes. Can you recollect what isotopes are? Yes, they are the atoms of the same element with different number of neutrons. That is the reason why, in spite of belonging to the same element, the atoms have different atomic masses. Because atomic mass is the sum total of all the protons and neutrons present in the nucleus. Placing isotopes in the table was a limitation. But as we know, in the modern periodic table, the position of elements was no longer based on atomic masses. They were based on atomic numbers. An atomic number is given by the number of protons. That means the different number of neutrons will not be a worry for us. So it was possible to place the isotopes now. Because all the isotopes of any particular element could be placed at one single place. And this place would be the position of that element in the table. So now can we say that chlorine 35 and chlorine 37 will be placed together? They both have 17 protons, which means they will have the same atomic number. Hence, they will be placed together. Lastly, we had the prediction and placement of undiscovered elements. The previous table by Mendeleev was based on atomic masses of elements. However, the atomic masses of elements were not arranged in a constantly increasing order. Hence, if newly discovered elements were to be placed in the table, then their position would be confusing. But why? It's simply because if the atomic masses of previously discovered elements were not in a regularly increasing manner, then how and where will we place the new ones? Just for the sake of understanding, let us assume some values for the atomic masses of two elements. Element 1 has atomic mass 300, whose position comes first, while element 2 has an atomic mass 297, which is placed later in the table, that is, after element 1. Now in this case, if a newly discovered element, say element 3, has atomic mass of 299, where will we place it? Between the two elements or after the second element with atomic mass 297? And this is what was happening with Mendeleev's periodic table because the atomic masses of elements were not placed in a constantly increasing manner. Some elements did have atomic masses less than the previously placed element. So placing the newly discovered elements will disturb the entire table. But in the modern periodic table, the position of elements was based on atomic numbers. So newly discovered elements could be easily added in between. Because the atomic numbers of elements are found to occur in a constantly increasing manner. This is how the important limitation of Mendeleev's periodic table got ruled out. And that is the reason why the new periodic table surfaced as the most useful tool for studying elements. The newly arranged table of elements was based on the modified law. Do you remember the name of this important law? Yes, it is the modern periodic law. So can you guess the name of the table that was based on this law? Yes, it was called the modern periodic table. Now let's have a detailed look at this modern periodic table, its properties, and a few of its important characteristics in the upcoming videos.